Welcome back. Let's do a couple of mole conversion problems here. In this problem, we're converting from moles of a compound to moles of an atom or an ion or a part, okay? And for that, we use subscripts, so that's a very important thing to keep in mind. And those are the numbers from the chemical formulas. So let's jump in and see how this works. For part A, we are interested in two things: this full chemical formula and then sulfur. Okay, sulfur. So let's analyze aluminum sulfate or aluminium sulfate. Al2, SO4, 3 means you have two aluminums and you have three sulfates. There's a 3 here, which tells you that you have a sulfate, and a sulfate. Okay? So what we want to do first is to create an equivalency. We want to say how many moles of sulfur are in one of those units. And the way you do that is you look at the subscripts here. There's a 1 for the sulfur, and there's a 3 outside the parentheses. So 1 times 3 is equal to 3 sulfurs. Now, I drew the sulfates all separate here, so you could see that there's definitely 3 sulfurs in there, okay? So we can set up the equivalency like this. We know that there's 3 moles of sulfur in 1 mole of the aluminium sulfate. Okay, so again, that 3 outside the parentheses is what makes it have 3 sulfurs. Then what we do is we set up the conversion. So we're starting with 3 moles of aluminium sulfate. Okay, and we create our fraction bar. And on the bottom of this fraction, we want moles of aluminium sulfate. Now, that cancels, okay? So that's the purpose of doing that. Now, on the other side of the fraction, we're going to have 3 moles of sulfur. And so on our calculator, it's 3 times 3, or just 9. But this has 2 sig figs, so we want to write 9.0. And let's write the units here very carefully. Moles of what? Moles of sulfur, okay? Now in B, we're interested in aluminium ions, and that's a part of this formula, right? And we saw previously up here how there are 2 ALs in this formula because of the subscript of 2. So let's write out that equivalency. So 2 moles of Al are found in 1 mole of this formula. Okay, and that comes from the subscript 2. So to set up the dimensional analysis, we start again with 3 moles of the compound. Okay, we set up our fraction bar to create the conversion factor, and we want 1 mole of the compound to be on the bottom. And that leaves us up on top 2 moles of aluminium. So 3 times 2 is 6. Make sure you have 2 sig figs there. And the units are moles of Al. All right. How about in part C? We're interested in the sulfate ions, okay? Sulfate is a polyatomic ion that's part of this formula. And there's 1, 2, 3 total sulfates. And that comes from the subscript 3. Okay, there's a 3 here, which means there's 3 sulfates. So we want to set up a equivalency. We say that there's 3 moles of sulfate, and it's easiest just to write SO₄², and that's equivalent to 1 mole of Al2 SO₄3. Okay, so this 3 and this 1, we're creating this not from any numbers in the word problem yet. Now when we do dimensional analysis, we want to start from the starting units. So we start with 1.50 moles aluminium sulfate. Okay, put your multiplication in your fraction bar. And we want the moles of the compound to cancel. So 1 mole of Al2 SO₄3 goes on the bottom. And that leaves us with 3 moles of SO₄2- or sulfate ions up on top. Okay, and so multiply that out. That's 4.5, right? So I messed up. The number should have been 1.5, not 1.50. So we write the final answer in 2 sig figs, which is 4.5 moles of sulfate. Okay. Now I've been kind of lazy canceling my units here, but it's a good idea to cancel the units that cancel so you can keep track of things. Okay. So that's how you do mole-to-mole conversions with crazy complicated formulas. I hope this video helped you. Please subscribe.